Hello, I didn't see you there. Welcome again to the Hawkins household. Hope you're enjoying your extended stay at your household. But I guess I'll talk about geometry since I have you here. Geez, over the last several days we've been working on a unit called transformations. And so far we've looked at two transformations. We looked at the translation, which is just a slide on the coordinate plane. We're just sliding things around. We looked at that in coordinate form, vector form, and in form of words. Then, over the last several days, we've been looking at reflections, and we needed a line to be able to do that. I started you off with the x and y axis. They were pretty easy. Then I moved to y is equal to x, which is that diagonal line. In the other directions, y is equal to negative x, so we also looked at that and flipping lines over that. And we looked at some horizontal and vertical lines and reflecting over those as well. Today we're going to kind of talk about, hey, what are you guys doing? Oh, whose turn is it? Let me see you go. Wait a second. Do that again, Joe. That reminds me of our next transformation, Joe. We're going to look at a rotation. A rotation is another type of transformation. And this is a good demonstration of that. And wait a minute. Why is there a random record player playing in the living room here? So take a look at this over here. Joe, come here, look at this. So this is rotating, right? Couple observations about this, Joey. What do you notice?
That the outside's going faster than the inside.
Yeah, the speeds on the different parts are going to be important. That's called angular velocity. They'll learn about that later. Also, I want you to notice that, well, here I have, me and Joey made this paper star, but we put it on a pin and it spins like that. So Joey, spin that. All right, so now, if you can go that way, you can also go the other way. Go the other way. So he was going this way. We can also spin it this way. So how many different ways can you spin it, Joey?
Two.
2 different ways. This way is the same as a clock. We call that clockwise. And if you go in the opposite direction, what's it called, Joey?
Counterclockwise.
Counterclockwise. Also, something I want you to notice, Joe, is look at the middle of the paper star. What do you notice about the middle?
It doesn't move.
Yeah, that doesn't move. There's always a center of rotation. Everything else is moving around it, but the center does not move. So now what I want to do is I want to kind of focus in on that center. Joey, come here. Who put an XY coordinate plane on the middle of our kitchen floor? All right, Joey, lay down. Let me show him something. So the center we're going to be using for all of our rotations to keep it simple is we're going to use this as our center of rotation. Maggie, what's that called?
The origin.
Good, that's the origin. So we're always going to use that as a center. So if I rotate Joey here, and I'm going to keep his belly on the origin, again, Joey, stop moving. So if you spin Joey and rotate him, keep his belly there, notice that the pioneers still goes in the same direction. So there is no reverse orientation about that. Now also notice I can spin it far, I can spin it short. So a short rotation would be like this. A bigger rotation would be like this. You measure rotations in degrees. Let's move the object that I'm rotating, and we'll keep the center in the same spot. So it's still at the origin. Now if I rotate Joey, again, around the origin, it would go like this. And basically, I could go a little rotation, or I could go big rotation. And notice Pioneer stays in the same orientation. That stays there. We're going to look at basically
Jenny.
4 different rotations. And they're going to be in degrees. So if I put his belly back at the origin then. One of the rotations we're going to look at is a 90-degree rotation, which would go like this. A 180-degree rotation, which would look like this. Then a 270 rotation, which would look like that. Now notice I was going in a counterclockwise direction. That's the default. You always want to go to the counterclockwise.
That's the way to go.
So, wait, I'm going to post probably another lesson on completing the notes for this section. And we'll show how it affects the XYs, the ordered pairs on the coordinate plane, and what happens with that. So,
Yeah.
I look forward to you on the next video. Thank you very much.